The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. I'm Sharon Dooley. I'll be the moderator for today's session. I think you're going to find it quite interesting. It's called SQL Server DBA Tips That Can Save Your Posterior. That's not what Guy calls it, but I was told that the way I had expressed it was vulgar, so I'm being careful. Our speaker is Guy Glancer. I'll tell you a bit more about him at the end of this section. We'd like to thank our sponsor. I don't know why my PowerPoint is not. Hewlett Packard Enterprise. It's their support that makes it possible for us to have a raffle and for every presentation and give away gift cards. We are just one of many virtual chapters. As you can see, a list of them here. If there are other topics that interest you, please go to your past profile and sign up for the other virtual chapters that interest you. For those of you who are not, for whom English is not your native language, there are some virtual chapters that give all their presentations in different languages, and you can see them listed here as well. If you're not familiar with SQL Saturdays, I urge you to learn about them. They're free one-day training events. They're like a mini conference. Many of the people who speak at SQL Saturdays also speak at the summit, and they're all over the world. And you can visit www.sqlsaturday.com to register for one that's in your area. I also urge you to join a local chapter. This gives you an opportunity for face-to-face networking and opportunities to present and share. Some of the local chapters have meetings at lunchtime, others have meetings in the evening. If there isn't a local chapter in your area, you can start one and you'll get help from PASS in doing that. Just contact ce@sqlpass.org. PASS is an all-volunteer organization. Yes, there is paid staff in the headquarters and all of that, but it's driven by volunteers. And you can volunteer for a small activity or a large activity, and you can do that as part of your PASS profile as well. Now, this isn't for the folks that are here, but I've discovered a lot of people find the recordings of these sessions on YouTube. And it's really beneficial to visit SQL Pass and become a member. It's free. And if all you get on YouTube is the recording, if you're a member of PASS, you'll be able to download supplemental materials like the scripts used by many of the speakers. Membership is free. Stay in touch with LinkedIn, Facebook, Twitter, whatever turns you on. And I have not corrected the title on this slide, so this is not the proper title. So let's just take it away. Our speaker today is Guy Glancer. Guy is a data platform MVP. He's the leader of the Israeli PAS chapter and also the CEO and founder of Madeira Data Solutions. His career has been focused on the Microsoft data platform for the past 20 years, performing various database roles as either an on-site DBA, an external consultant, or a speaker. Guy is involved in many activities in the Microsoft data platform community. He occasionally speaks at community events such as PAS Summit, SQL Bits, SQL Saturdays, and user groups around the world. He also co-hosts the SQL Server radio podcast. And now I want to turn this meeting over to Guy and let him do his thing. Okay, it's all yours, Guy.
Thank you, Sharon. Thank you very much. And welcome everyone to SQL Server DBA tips that can save your, I'm not going to say that. So I wanted to share with you some of the tips and the best practices that I gathered throughout my career. There are so many of them, and I only have 1 hour. So I just gathered 10 tips that I think are very useful, practical, interesting to SQL Server DBAs. I hope you'll find them so. I don't have much time. I hope I can get as much as I can knowledge to share. So, well, about me, you know about me everything right now. I just want to say that there will be a recording of this session, and I will also make the presentation on all the demo scripts. I have a lot of scripts here. I will make them available, so you'll be able to download everything. And with that, I think we will start. So, tip number 1, SQL Server setup best practices. I wanted to gather all the best practices that I use when I install a new SQL Server instance. And I'm sure you have your own ideas, and please feel free to share them with us. So, first thing, install SQL Server on a dedicated machine. It's not always something you can do. Sometimes there are all kinds of limitations, but if you need a production box and you need it to perform well, then don't install all kinds of other database platforms or Exchange Server or SharePoint or whatever on the same machine. Give SQL Server its own box. Only install the required SQL Server components. SQL Server nowadays comes with many services, and if you just, during the install, you just check everything, install all components, it will install all kinds of services. Some of them might be even running, even though you don't need them. They consume space, they consume resources. You might not need them, like full text search, for example. If you don't use full text search, don't install it. If you don't use analysis services, don't install it on the machine. Just install the components that you need. The best practice in terms of security is to use domain accounts for the SQL Server, the various SQL Server services. It's more secured, it's easier and more efficient to manage security and manage accounts using the Active Directory and not within SQL Server. So create a dedicated domain account for each SQL Server service and use those accounts. During installation, during setup, SQL Server setup will assign only the relevant permissions to each one of the services. Of course, you should install the latest updates for your SQL Server version, the latest service pack or cumulative update. Microsoft has recently modified the incremental servicing model. So now each cumulative update is considered just like a service pack. It is thoroughly tested, and Microsoft recommends to install every cumulative update as soon as it becomes available. Of course, you need to test whenever you install a cumulative update or service pack. You need to test and make sure that it does not affect your production server in a bad way. And here is a link to a website that displays all the builds, all the cumulative updates versions and SQL Server builds for each version, so you can make sure you can verify what is the latest build for your specific version. If you have antivirus software on your production machine, then make sure it is configured to skip database files, your MDF, NDF, LDF files. There's no reason to scan them for viruses. and this can really hurt performance and slow down your SQL Server and cause all kinds of issues. So make sure you don't do that. What else? Instant file initialization. This is an important feature if you're going to create a very large database with very large files. When you create the data files, if you don't use this option, SQL Server will allocate space on the disk and it will zero out all the bits on the file. This might take a lot of time. If you use this option, SQL Server will just allocate the file without zeroing out the bits. The same goes for when you restore a database, and this is very important because if you are now in downtime and you need to restore the database, you want to make sure that the restore time is as fast as possible. Also, when files need to grow, same idea. So in most cases, you want to enable this feature. The only drawback is a security issue because if you create a file on the disk on a space where some other important file was there before, then it is possible to see the details, the data in the previous file if you have the access privileges for SQL Server. But if this is not the case, then enable instant file initialization. You do this by going to the security rights, and you need to assign a specific security right called perform volume maintenance security right for the SQL Server service. I will show you later in the demo. Yes, perform volume maintenance task privilege. A very important thing to do is to leave enough memory for the operating system. By default, when you install SQL Server, the max memory configuration option is configured to the maximum, and SQL Server will allocate as much memory as possible. And in most cases, it will not leave enough memory for the operating system, and this will cause performance issues. So it is recommended to always leave some memory for the operating system. And this is really a rule of thumb. You need to test your specific environment, your specific machine, but you need to leave, for example, if you have 32 gigs of physical memory, then you should leave something like 6 gigs for the operating system. So allocate the max memory for SQL Server to be 26 gigs, just as an example. Another important thing is to manage the SQL Server logs. The SQL Server logs, by default, there is the SQL Server error log. There is also SQL Server agent error log. And by default, for the SQL Server error log, you have 7 files, and they are in a rollover fashion. So whenever you restart the instance, a new file will be created, and it will cycle until the most old file. And sometimes it's not enough to have only 7 files, and also another problem is that you don't want to recycle only when there is a restart. So what you can do, let's go to the demo. So we can use XP enum error logs. One means SQL Server error log, 2 is the SQL Server agent log. Let me just close this, okay. So we can see in this case, I've already done what I'm going to show you. So I have 31 error log files. Usually it's 7. It's the current one and 6 more. And this is how you can change by code the number of error logs. So you need to change it in the registry. So here's how I change my configuration to have 30 error log files. Of course, you can also go to Management, SQL Server Logs, and by right-clicking Configure, you can do it here using the GUI. You can cycle the error log manually by running sp-cycle error log, like this. Same goes for the SQL Server agent. If you specify 2, you can see the number of error logs. We have 10 for the SQL Server agent. This is the default. If you go to MSDB, we have DB cycle agent error log to cycle the SQL Server agent error log. Same idea. Okay. So my recommendation is to use 30 files and to have a job that recycles the log every day at midnight. This way, you control the number and the size of the error log files, and you are going to have a log file for each day, and this will make it much easier to troubleshoot and to investigate issues. You know, if something happened 2 days ago, you know where to look for this event, and it's much easier than having one big file for the last 2 months, and then some other small files, etc., etc. Okay, so this is the recommendation about the error log management. There are some configurations in SQL Server that by default are not the best thing to have. For example, backup compression. I think that this is something you always want to have. You always want to compress your backups. I haven't seen a single case where this is not a good thing to do. Of course, it has some CPU overhead, but it's really nothing. So set the default to be backup compression. The same goes for backup checksum. There is another option, meaning that for every backup, SQL Server will calculate the checksum and also verify the checksum for each page during the backup operation. I think this is important. This should be the default. The default is disabled, so enable it. Another option is optimized for ad hoc workloads. Now this configuration is relevant for workloads where you have ad hoc queries without parameters, and this might lead to a lot of compilations and a lot of usage of the plan cache. And what this option does, it says the first time an ad hoc query comes along, it will be compiled and executed, but the execution plan will not be placed in cache, in the plan cache, saving space. Only in the second time, if the exact same query comes along, it will be placed in cache. This might improve performance in case of ad hoc workloads, but even if it's not an ad hoc workloads, it does not hurt, maybe just very little. So from my experience, in my opinion, this should always be enabled. And this is not the default, so make it the default. Another thing which is very important is the duck connection. There is a dedicated admin connection in SQL Server which will allow you to connect to SQL Server even if there is an issue and it's not possible to connect regularly. So you can use the duck to troubleshoot problems, but the duck can only be used locally on the same machine. If you want to use it remotely, you need to enable remote admin connections. And this is very important because when a crisis comes along, you don't always have access to the machine using RDP, for example. And also, if this is a cluster instance, it is clustered, so you cannot use the duck unless you use remote admin connections. So it's very important to enable remote admin connections beforehand. There are some trace flags that are, again, I think they are very important to enable by default. 1117 means that all files in a file group grow together, and you want that in order to have efficient round-robin distribution of data between the files, especially for Temp DB. 1118 means don't use mixed extents. When you allocate the first pages for a table, use uniform extent. This is very important for Temp DB, where you create a lot of small temporary tables, and you always use the same mixed extents, and you have contention on those allocation pages. When you do that, you have a lot less contention because you don't use mixed extents anymore. Another one is 2371. This changes the default behavior of SQL Server in respect to the statistics threshold. When to update statistics? The default behavior is every 20% row modifications in a table. This will trigger auto-update statistics. For very large tables, this is usually not a good threshold, and trace flag 2371 changes the algorithm. It's not a fixed number, it's not 20%, it's some other percentage that it depends on the size of the table, the number of rows in the table. The more rows in the table, the less percentage value you will get. And this tends to be better for most scenarios. So again, I think this should be the default. And the last one, trace flag 3226, this one suppresses all the successful backup log entries. By default, whenever a backup is successfully completed, a log entry will be placed in the SQL Server error log. And if you have lots of databases with lots of transaction log backups, for example, running all the time, this will cause a lot of overhead on the error log. So use trace flag 3226 to suppress those. And then there are some changes in SQL Server 2016 that it's important to know. So for trace flag 1117, we now have database options. Using the alter database statement, you can specify whether to auto-grow a single file or auto-grow all files together. And the default for Temp DB is to auto-grow all files together, which is good. 1118, it's not needed anymore because now we have another database option which is called mixed page allocation. And for Temp DB, by default, it is off. meaning no mixed extents. Trace flag 2371 is now the default behavior in SQL Server 2016, so you don't need to mention that as well. And only trace flag 3226, no change, so you still need to enable it if you want to use it in 2016 just yet. And sorry, I closed it. So let's go to the best practices demo. Okay, so for the physical memory, I can run this query, DMO sysmemory. I have 16 gigs on my laptop, and this is how I change it. I need to show advanced option first, and then max server memory. I'm going to, in our example, I have 16 gigs. I want to have 13 gigs for SQL Server, so this is how you do it. Of course, we can do it through the GUI as well. For the SQL Server logs, I showed this before. This script, I'm not going to run it now. This script creates the job that runs daily and recycles the SQL Server log and the SQL Server agent error log as well. And this script changes the default behavior for backup compression default, backup checksum default, optimized for ad hoc workloads, remote admin connections. For the trace flags, if you need to enable them, if you're not in SQL Server 2016, you need to use the configuration manager, and then you have the startup parameters. You need to add -t and the number of the trace flag, and of course restart SQL Server. Okay, so this is for the first tip, and some references here, some blog posts that I wrote. One of them is about, again, tips for setting up SQL Server, and a specific blog post about SQL Server error log management. Okay, tip number 2, contention on allocation pages in Temp DB. Yes.
You want to do questions on the on tip 1 first?
Yeah, sure, let's do that.
Okay. When you say dedicated machine, do you mean dedicated physical server or dedicated virtual machine?
No, I was referring to the dedicated administration connection. I think
No.
Oh, sorry, you talked about the first thing, dedicated machine.
Yeah.
Yeah, virtual is fine as well. I was referring to the guest machine. So it could be either physical or virtual, but what I wanted to say is that on the same guest, the same operating system, don't install other applications.
Okay. Should you use regular domain accounts or managed service accounts?
Well, that's a good question. I think you should use regular. If you're in an Active Directory environment and you manage all the accounts in Active Directory, you should use domain accounts, regular domain accounts for SQL Server as well. There are many options to use service accounts, to use local service or local system accounts on the machine, but I think the best practice is to use regular domain accounts for that.
Is instant file initialization necessary with flash storage?
Well, good question. I don't know. I don't have specific numbers. How much can it affect performance? I think there will still be a difference, and if you don't have the security issue that I mentioned before, then there's no reason not to enable it.
Regarding in-memory configuration, how important is setting the min memory as well as the max memory?
Well, I don't think it's important at all. I think we should let SQL Server assign as much memory as it needs. It's very important to cap it to have enough memory for the operating system. But again, if we're on a dedicated machine, SQL Server is the only thing that is running. Min memory has no effect.
Is it good to use domain accounts for an application or a SQL account? I think he means Windows authentication logins or SQL Server authentication logins.
Oh, okay. Well, the best practice, again, if we're in domain environment, is to use Windows authentication. You don't have to pass the password over the network each time. You don't have to manage different accounts and different passwords. You just manage everything in the Active Directory. So this is the best practice approach. Of course, there are all kinds of limitations depending on your environment. Where you can't use domain accounts and you need to use SQL Server accounts. So if you have to, then of course use them. But that's the best practice.
Okay, one more question, and then I'm going to let you go on. Is trace flag 4199 still required in SQL Server 2016?
Okay, so threat flag 4199 affects all kinds of behaviors related to the optimizer. In 2016, it is not needed anymore. All the behaviors that are included in this trace flag are now part of the engine of the optimizer in 2016, but you have to use the compatibility level of 2016. So even if you install 2016 and you restore a database for 2014, for example, by default the compatibility level will remain 2014, and you will not have all the changes of the optimizer. You will still need to use this trace flag. As soon as you go to the compatibility level of 2016, you don't need this trace flag anymore.
Okay, go on to your next tip.
Great, thank you. So the next tip is contention on allocation pages in Temp DB. This is a very common scenario because we are using temporary tables in Temp DB. Those temporary tables, again, we talked about it before regarding mixed extents and uniform extents. Even if you use uniform extents, if you have a heavy workload, a lot of concurrent connections creating and allocating and reallocating pages for temporary tables, you are going to have contention on those metadata pages for the allocations. And there are all kinds of recommendations, best practices for the number of files in Temp DB, because if you increase the number of files, then the loads on the contention pages will be split between the files. The best practice as of today, because it changes all the time, is to use, if you have up to 8 cores, then use the number of files in Temp DB, the data files, as the number of cores. If you have more than 8 cores, use 8 data files, and you need to monitor and to see how much contention you have, and based on that, you need to see if you need to increase or decrease the number of files. So the way to monitor the contention, okay, I have this query here, courtesy of Robert Davis, and there is a reference to his blog later in the presentation. So this query checks always waiting tasks, all the tasks that are currently blocked for any kind of page latch wait type, and looking for, according to the offset, the page number, we know which type of page is it. So currently nothing is running, and let's create some contention. So I'm going to use this query, just create a table and insert it many times, create insert drop, and I'm going to run it from multiple connections. So this is 1, this is 2, this is 3, and now if I run this, hopefully, no. Okay, let's have another one. Okay, we got something. Okay, so just an example. It's not exactly what I wanted to show you. I need some more load for that. So this session is now blocked. Okay, and we can see that the resource description, this is Temp DB, this is file number 1, this is the page number. Specifically, this is not an allocation page. This is some data page. But usually we're looking for the PFS, GAM, or SGAM pages, which are allocation pages. And if we see a lot of those, then it means we have contention on allocation pages, and we should try and increase the number of files. And this is how we can monitor over time the contention on Temp DB. Okay, so those are the references, breaking down Temp DB contentions. This is the blog post by Robert Davis talking about it and specifying the script. And also a very good article by Paul Wendell. Temp DB should always have 1 data file per processor core. So he talks about the best practices of how many data files there should be in Temp DB. Any questions about that? Sharon? Okay, I guess we can move on.
No questions.
Okay, thanks. So tip number 3, file sizing. We need to be able to size our database files in advance. The best thing to do is to plan ahead. If we know how much data we're going to need in our database files, including future growth, then we should allocate enough space for our data files. Otherwise, we're going to have our files grow automatically when they are full, and this is not a good thing. This creates overhead when it happens. It creates massive IOs. It creates fragmentation on the file. It's not a good thing, so we should avoid file out-of-growth as much as possible. And of course, we need to take into account the data, the indexes, and everything else that is going to happen inside the database. So we should look for file growth. sorry. And then we should plan if we allocate enough space, but after 6 months we see that it's not enough, and the file is also almost full, we should plan for a manual grow, and don't let SQL Server auto-grow when a file is full, because this might happen in the worst time for you, at the peak hour in the day, for example. Okay, you still enable file groups just as a safety measure, because you don't want everything to go down. Use fixed file group. You can use for each data file. You can specify either a fixed size in gigs, for example, or a percentage. Don't use percentage, because this will change over time as the file increases. It might not be predictable at some point in time. Use fixed numbers, and also use max size unlimited. I don't see a reason to max. If there is still space on the disk, let it grow if you have to, because otherwise it's downtime. You don't have any access to the database. So I want to show you. Oh yeah, I think we need to close all those. And last one. Okay. File sizing. So I have here a query that I'm going to go into details. You're going to have access to this query later. I'm just going to database files and file groups just to see what's in there. Okay, so I have all the information about my files, the data file and the log file, the file size, how much size is allocated, how much space is allocated, and how much is unallocated yet. Okay, and also the percentage. So I need to monitor this value, and if I see that the percentage of unallocated space is low enough, let's say 10%, 15%, maybe 5%, depending on your environment, then I should plan for manually growing the file. Don't wait for auto-growth. And again, I can see here the auto-growth type and the value. In my case, 512 megs. You can also look at the space used by using SP space used for the database, and you can see the numbers for the entire database, the database size, how much unallocated space. This might be confusing because the size is the data plus the log, and the unallocated space is only from the data. Okay, so make note of that. And also this only for the data, how much is reserved, how much goes for the data, how much for the index, and how much is unused. Now unused is not like unallocated. Unallocated means data pages that are not allocated at all. Unused means data pages that are allocated to something, to some object, but they are currently not in use. For example, if we use mixed extents, then the entire extent is allocated, but some pages inside the mixed extent might not be used yet. Another option is to go to sys allocation units and then aggregate all the data from there to see how much we are using, and we're going to get the same numbers more or less. So I'm not going to go into detail here. If you want to change it, you should change the auto-growth settings in your database. Then this is how to do it, using a script, modify file, and change the file growth and the max size for each one of the files. In 2016, one of the changes is that now during the installation wizard, you can specify the number of Temp DB file, and you can also specify the default size and the default max and the auto growth for each data file and log file in your instance. The previous values, the default values, were not good at all. Let's call it that way. The new values are slightly better, but still, I think it's 64 megs by default. Of course, you should change them to something that is more appropriate to your specific database. And with that, I'm going to move to the next one.
Okay.
Yeah,
I got questions. Does each file for Temp DB need to be on its own drive?
Well, this would be better if you can afford it. If you can put each data file in a separate drive, you get more parallelism, you get better performance. It's not necessary. Even if you use the same drive and you have multiple files, you're still gonna have better performance by reducing the contention on the allocation pages, as I mentioned before.
Okay, question about contention of Temp DB. What is the recommended size of each Temp DB file?
Well, that's a great question. It's very hard to answer because it really depends on the workload. The size of Temp DB has to do with what you do with your database, how many temporary objects you create, how many internal objects like spools you have inside execution plans, how many cursors you use, because cursors also use Temp DB. If you use snapshot isolation level, for example, then you're going to use the version store in Temp DB. Temp DB has a lot of usage in the instance, and you need to run your workload in some test environment or something and try to see from there how much space is used by Temp DB, and this is what you're going to need. It's very hard, very difficult to predict what is the optimal size for Temp DB in your environment.
What is the recommended RAID level for Temp DB?
Well, actually, the recommended thing to do is to put it in memory, either memory optimized tables. There is one option to do this this way, or to use some kind of flash disks. Temp DB needs to be as fast as possible. We don't need redundancy for Temp DB because it is created anyway. It's temporal. It's temporary. It's created anyway each time we restart the server. So just use different files again, either on the same disk or different disks. There's no need for any RAID configuration in this case.
Does the RAID level matter for flash storage?
Well, RAID, the main reason to use RAID levels is for redundancy. And for that, yes, it doesn't matter which type of disk you're using, because if one disk is going to fail, you still want to be able to access all your data. So you're going to need to use either RAID 1 or RAID 5 or whatever. So it's still relevant. If we're talking about performance, and this is something else, I don't think that RAID is the issue here. Performance-wise, the issue is more how many files you have and what type of disk you're using and stuff like that. So again, RAID is for redundancy before anything else.
Should user databases stay in the primary file group? I think the questioner means should data files stay in the primary file group for user databases.
Well, if you're using multiple file groups, and there are all kinds of reasons to do that in your user database, then the best approach is to leave nothing in the primary file group. Only the system objects are going to reside in the primary file group, and use everything, all your objects in different file groups. But if you're using just the primary file group, then of course everything is going to be there.
There's an observation that there's no worker thread contention by having multiple Temp DB files on the same drive.
Again, sorry, no worker threads?
No worker thread contention by having multiple Temp DB files on the same drive.
Oh, so when you have multiple files in the same file group, you're going to have multiple threads running against those files. And yes, this can reduce contention. I don't think there's no contention, but it's less contention. Absolutely.
Should we separate non-clustered indexes and clustered indexes to different disks?
I'm not sure I understand the question. I don't think so. But you can have the both on the same disk. Again, if you can afford it, if you have enough storage, enough disks, then separate everything. Put different instances, different databases, put the data files and the log files and the backup files, everything on separate disks. But if you have limitations, you don't have enough disks, then I don't see a reason why specifically you should separate clustered, non-clustered. Well, clustered, of course, you're going to have shared storage anyway, so I'm not sure it makes sense.
Okay.
Okay, so I'm going to tip number 4. Wow, it's late. The Rita board problem. So this scenario goes like that. I have here an application called the problematic application. I'm going to run it. It does all kinds of things behind the scenes, and the scenario is like that. Okay, the users tell me there is this store procedure that takes too long, very long, and please troubleshoot, see what you can do about it, try to improve it. And of course, what we're going to do is to start profiler. And I'm going to use just blank. And for the events, I'm going to go to store procedures and I'm going to only use the RPC completed event. This will give you all the events of store procedures running from the application as soon as they are completed. And I'm going to use a filter only for problematic application. This is my application. This is the name in the connection string. Let's run. Hopefully, I'm going to see some workload. Okay. So this is an example. This is the problematic store procedure. And then, of course, what we can do is take this, take some example, okay, and go back to Management Studio and paste it here, okay, like this. Of course, I need to include actual execution plan. Here's the store procedure. Okay, now as you can see, it took me just 1 second. If we look at the profiler, we can see that the duration, okay, is around 5 seconds on average. Okay, so users complain because it takes 5 seconds to run. We're trying to troubleshoot in Management Studio, and we see that it takes less than 1 second or just 1 second. Okay, so we can tell the users everything is great, it takes 1 second, but they say no, look at profiler. It takes 5 seconds. Look at the application itself, it takes 5 seconds. So what's going on? If we look at the plan cache, okay, look at procedure stats for this specific store procedure, then we can see that we have 2 execution plans. One of them is used by the application, this one, 22 accuracy so far. The other one is used by me, by Management Studio, only 2, because I ran it twice, okay? And yes, we can see that the average elapsed time for the application is 4.5 seconds, and for me it's less than 1 second, okay? We can also see that the execution plans here, they are different. And the question is why? Why do I get a different execution plan than the application? We can use SysDM exec-plan attributes to see the attributes of each execution plan, and there is a specific attribute called set options. This is all the set options for the session running the execution plan, like set ANSI nulls and set read abort and stuff like that. And if we look at this, this is a bitwise number, so it represents a combination of bits. What we can see from here is that they are different. And as soon as there are 2 sessions running the exact same query but with different set options, they will get different execution plans. Okay? So this is the reason why we got different execution plans. Now I'm going to use a bunch of IIF statements, expressions, or case expressions to see which specific set option is the offending one. So we can see all the set options here. We can see that they are the same in both sessions, both execution plans, except for this, the arith abort. Okay, so set arith abort is a setting, the session level that affects the way queries are evaluated. Specifically, it means that if you have some kinds of errors, like let's say divide by 0, then if set arith abort is set to false, then you will have a warning. But you'll get null, okay, but not an error. And if you have set arith abort set to true, that you will get an error and the query will be aborted. This affects the execution, and of course you get a different plan because of that. And the reason is that in Management Studio, by default, set arith abort is set to true. If we go here, okay, this is default in Management Studio. While in the .NET application, the SQL client, set arith abort is set to false by default. So this means that every time you troubleshoot something in a .NET application, you try to reproduce the behavior in Management Studio, you will get a different plan. Sometimes the different plan will be just like the application plan, so there shouldn't be a problem, but sometimes, and it happens quite often, you will get a different plan and you will spend a lot of time trying to troubleshoot something that is not really happening in the application. Just to show you, if I change it in Management Studio, set arith abort to off, and I execute the same store procedure, now it will take more than 1 second, 5 seconds or so, or maybe even more. Okay, whatever. This is the plan used by the application. Okay, let me change it back to on. So this is unfortunate, but this is the behavior of SQL Server and .NET, and you need to make sure that when you troubleshoot queries, either change Manage Studio to set a reader board off, or change in your application, whenever you open a new connection, the first thing you should do is set a reader board to on, to make sure, because this is also the best practice, the recommended setting by Microsoft. So change set a reader board to on, and then you will have the same setting in Manage Studio, then you know what you're looking at. All right. Questions?
Just one. Isn't it lighter on SQL Server to use extended events instead of profiler?
Yes, great question. I'm a big fan of extended events. Extended events is lighter. It has less impact on performance than profiler. It also has more functionality, all kinds of targets, and you can do some things that you cannot do easily with profiler. So yes, the recommended thing to do is to use extended events. Unfortunately, most DBAs still use profiler, including myself, and I didn't want to go into something that people don't recognize, so I prefer to use profiler. But yes, please learn how to use extended events and use extended events instead of profiler. It's much better for many reasons. Okay? So
in just the 1 second, I'm not sure. Wait a second. Let me undock this. Should the developers have any best practices for set options?
Well, you can look at MSDN. There are some recommendations by Microsoft, except for set a reader board, which the default in the .NET client is wrong. All the rest are okay. So you can, if you can, change in your application, set a reader board to on whenever you open a new connection.
Okay, I think that answers the second question, the last question, which is how do we get it to run in just the 1 second for the application? You need to make sure set a reader board is
which, exactly.
True or false?
Well, actually, it's a good question. The reason, I didn't talk about it, but the reason we had a poor plan in Manage Studio, in the application, is not, it has nothing to do with set a reader board. Okay, set a reader board in this case only created a scenario where we have two distinct execution plans, and we were unfortunate to get one poor plan for the application and one good plan for Manage Studio. The reason we got a poor plan for the application is completely different. It can be all kinds of reasons. In this case, I simulated it by using parameter sniffing, by using an uncommon parameter value in the application to get a poor plan. And then in Manage Studio, I used a different value for the parameters, so I got a different plan. So in most cases, a reader board is not the reason for a poor plan. There is some other reasons. But what I'm trying to say here, and the important thing is that when you troubleshoot a query plan in Manage Studio, you are not looking at the correct plan. This is not the plan used by the application. So make sure you look at the correct plan. Now let's talk about how to monitor query statistics. I don't have much time, so I'm going to go through this quite fast. Actually, I'm going to show you another thing. Let's look at this one. Again, I have a blog post. I have a link later to this blog post which explains everything, including this script. What this script does, just quickly, creates a database, and it creates a function for statement level text. I'm going to use sysdm exequery stats, a very common DMV. Sysdm exequery stats includes statistics about all the queries, all the execution plans that are currently in the plan cache. How many times they were executed, when was the last time they were recompiled, what is the total average mean max elapsed time, or CPU time, or logical reads, or number of rows, etc., etc. A lot of important statistics, and you can get from this view very easily the top 10 queries according to CPU or elapsed time or whatever you like. There are some gotchas, there are some things you need to pay attention to. One of them is that if you have a batch or a store procedure with multiple statements, then you will have multiple rows. Each row in query stats represents a single query, and in order to get the appropriate statement text, you need to create a function like this one. I create a scalar function that receives the SQL handle, statement start offset, and statement end offset, and returns the specific text of the query and not the entire batch. This is how we can easily recognize for which statement we are looking at statistics right now. Then I'm creating here some management table for snapshots. I'm going to take snapshots of these query statistics. And essentially what this script does is it creates a job that will run every minute or 5 minutes. You can change the schedule, of course. It will take snapshots of query statistics. And by using some utilities, some functions, I will going to extract all the information I need from query stats. And then I have somewhere at the end, I have a function, this one, that will allow you, where is the parameters of the function? Okay, I have a first snapshot date time, second snapshot date time. Using this function, I can now look at query statistics for a specific period of time. Let's say I know there was an issue with my database 3 hours ago. I can specify a range of time around 3 hours ago, and I will get the statistics for that specific period of time. So this can be very helpful to troubleshoot performance issues on your machine. You can, again, take this script, run it on your instance, configure the schedule, change some things to match your environment, and use it. The things, again, you should pay attention to is that how you can look at the specific text, at the specific plan for each row, representing only the query you're looking at. And there are some other things, but again, I want to have enough time for other things. So just look at the blog post, which is, oh, it's not here. Okay, I'm going to change the presentation, and I'm going to share on the updated one with the link to the blog post. So choosing the right indexes. When you need to configure the right indexes for your database, there are all kinds of things you can do. One of them is you can check for unused indexes. We have a DMV. Index user statistics, and you can see which indexes are not being used, or they are being used for updates, but they are not being used by seek or scan operations, so they are redundant. You can also look for redundant indexes. I have a script looking for all indexes which are either identical or one of them covers the other. Okay, so for example, if we have an index on A and another index on columns A and B, so for most cases, the index on A is redundant because index A and B can also serve as a predicate for A. Okay, so you have a script to look for all those occurrences in your database. Foreign keys usually are used in join predicates, and in most cases you want to have an index on the foreign key column. So there is a script here to look for all the foreign keys in the database without indexes, which might be good candidates for adding indexes. There is the missing indexes feature used by the optimizer. Don't trust it. It's very problematic because the optimizer only looks at a specific query when suggesting missing index, and it doesn't take into account the entire workload, and this can lead to unpredictable results. You can also use the database engine tuning advisor, which you can provide a workload, and it will take into account the entire workload. So the recommendations should be much better, but don't trust it just as well. Well, you can take it as let's say a second opinion, get some ideas, but don't just apply the indexes suggested by the DTA because again, it's very sensitive to the workload that you provided, and if the workload does not represent correctly your production environment, this can be risky. You can end up with the wrong set of indexes. So all the scripts, so for example, user statistics, to find unused indexes, I'm going to select from index user stats, and I'm going to order by user updates minus all the 6 and scans. Okay, so I'm going to see first all the indexes that are used for updates. Well, okay, I don't have any workload here on my laptop, so sorry, no interesting numbers here. In your production environment, you should see at the top all the indexes that are used only for updates and less for reads. Okay, you should consider removing them. This query should produce, let me include actual execution plan, should produce a missing index. Oh, I got it for, I changed the indexes, sorry. I have this index already. So anyway, when you look at the execution plan, if you have a missing index recommendation, you'll see it here. You can click it, you can see the details. You can also run this query to look for all the missing indexes recommendations for your database. Okay, so I have some recommendations here. Again, in your production environment, you're going to have a lot of more data here. Don't trust this. Okay, maybe you can look at it. Maybe it can give you some ideas, but don't trust it. In this example, I'm going to create 2 indexes, one just for the name column, the other for the name and country. Oh, I done that already, sorry. Okay. And this query, which is quite long, we look for redundant indexes in your database. Yes, I know. It ends here. Okay, so here is the long index name and the long index columns, name and country, paired with the short index, which is only for the name. Okay, so you will get all the instances of potentially redundant indexes in your database, which you can evaluate and see if you can remove them. And this script will give you all the foreign keys without corresponding indexes. Okay, so I got a few in my database. So these queries should help you choose the right indexes for your database. Okay, I don't have much time. I'm going to go through the next very quickly. The next tip is the ascending key problem. The problem is, in most cases, you have a very large table in your OLTP. I'm talking about OLTP databases in this case. You have a very large table with some date and time column, and you have ascending key rows are inserted in ascending fashion all the time, very quickly. And there are issues with statistics because if it's a very large table and you need to trust the auto-update statistics, it might take a while before it is triggered. And let's say users always read the last week from the table, and it has been a week since the statistics were updated. So according to the statistics, there are 0 rows in the last week. And of course, there are many, many rows for the last week. This will lead to poor plans. The solutions, first, you can of course update statistics manually. You don't have to wait for the auto-update statistics to trigger. You can have a job that runs daily, for example. This might be a problem because if you use just a sample of the table, it might not be accurate enough. And if you want to use the full scan of the table is very large, this might be very intensive and you cannot allow yourself to do it every day. But if you can, this is a good solution. I talked about it before. You can use thread select 2371, and this is also the default behavior in SQL Server 2016, which changes the threshold. You don't have to wait for 20%, much less than that. This can solve your problem. Since SQL Server 2014, we have a new cardinality estimator, which deals with this scenario specifically. It recognizes the pattern of the ascending key problem, and it will estimate how many rows should be there, even if the histogram, the statistics says that there are no rows. You can also use, starting SQL Server 2014, filter statistics. Sorry, this is something else. You can use filter statistics since SQL Server 2008, which means you can create a filter statistics only for the last week, and this will be very, very accurate, and you can have a job that creates it, let's say, daily. This is a very good solution. It requires some development and maintenance, but it works very well. And also, since 2014, you can use incremental statistics for partition table. If the table is partitioned, you can specify the statistics are incremental, and then they are computed only for specific partitions that change, and also the threshold is computed only for specific partition, and this will give you much better results. Okay, so I don't have time to show the demo script, so you'll have all the scripts. I want to move on to the next one. Delayed durability is a new feature since SQL Server 2014, and it's very interesting. The way it works, this is a fully durable, a regular transaction. So when a request comes along, we change some data page in the buffer pool, and we also write the statement itself, the operation, in a transaction log buffer in memory. And then we have this transaction log buffer has to flush into the transaction log file on this. We have the write log wait type, and only then we get a commit. Okay, and this happens again and again and again. And at some point, we also have a checkpoint which flushes the buffer pool into the data file. When we use a delayed durability transaction, as soon as the data is written to the transaction log buffer in memory, we get a commit. We don't have to wait in order to the transaction log buffer to be flushed to disk, and this can speed things very, very fast. But this, of course, can also mean, that we can lose data. Okay, because now if something happened and SQL Server crashes, we have some data in the transaction log buffer in memory. It's not persisted, we might lose some data. This is a very great solution for some all kinds of log tables, session tables, where we can afford to lose some data, but we can get a very big boost in performance for all those inserts. But of course, this is not relevant for tables like financial tables, transactions tables, where we cannot afford to lose data. But you should certainly consider this in your environment. Again, I have a full script showing a demo of everything. I don't have time to show it right now. The 9th tip is log storage, large object storage. There is a table option. Again, it's in the script. There is a table option. The default behavior for tables is if you have large object data types like varchar max or XML, then if they can fit in the data page, they will be put in the data page. Otherwise, you'll have a pointer in the data page to a large object data page, and it's going to be placed in that page. Sometimes you want a different behavior. You can change the table option to say that every time you use a large object value, it is going to be put in a large object page and not in a regular data page. Because if you have queries that don't need to query the large object values, then this would give you much better performance. You get much less I/O because you don't have to scan the large object values themselves. Okay, again, there is a script there. And the last one, refactoring opportunities. I gathered together all kinds of scripts that I use with customers. When I go to a customer for a new database, then there are scripts here to look for tables without a clustered index, tables without a primary key, the distribution between clustered and non-clustered index on primary keys, tables without check constraints, foreign keys without indexes like I showed you before, tables that use all kinds of data types that are inappropriate like text and image or float and real, and some others. There are many scripts there that you can use to check if you have any issues in your database that might require refactoring and improving your database design. So I apologize for running fast. Okay, these are the things I just talked about. I apologize for running fast at the end. You will have all the scripts and the presentation itself with all the links to the blog posts and the references. And I don't know if I have more time, but if I have more time, I'll be
we've got a couple of questions, and people will drop off. But good that you mentioned parameter sniffing. Any guidelines for preventing issues with parameter sniffing?
Well, I have a complete presentation about that. I will try to answer it shortly. If you have non-uniform distribution, you have all kinds of values with different distributions in your column, then what might happen is that for each value used as a parameter, you will get a different plan. And the first value that you use will generate a plan, and then you have to reuse the same plan, which is not good for all cases. You can do all kinds of things. You can recompile the store procedure every time, for example. You can use option optimize for to instruct SQL Server to use a specific value for the optimization, for the creation of the execution plans. Or you can use some other method where you manage your own distribution in your own user table, and then you have a store procedure that first checks the value against your distribution and then decides which store procedure to use, and each store procedure will get a different plan. This is a more complicated solution, but it gives the best results. I have a blog post. I can add it to the presentation, maybe at the show notes. I have a blog post, a series of blog posts actually about parameterization, detailing all those possibilities. So I'll add it to the presentation.
I've got several people have said thank you, and it's a great presentation. Did I read is delayed durability set by table or database?
Okay, delayed durability, you can set it at the database level. You can either set it to forced, meaning all transactions in the database are going to be delayed or you can set it to allowed, and then you can specify per transaction. During the commit statement, you can specify whether this specific transaction will be delayed or not.
Blog link is very important. Please share. So fill that in before you send me the slides.
Okay, sure.
Okay. Folks, every session is recorded. Guy's going to send me the slides and the scripts, and they will be at dba.sqlpass.org on the meeting archives page, probably by Friday, along with the recording of the presentation. Okay? Got it? Thank you for an excellent presentation, Guy. It was fascinating. Next time we'll schedule you for 2 sessions.
Yeah.
Plenty of time.
Sorry about that. Okay, thank you very much.
Thank you. I'm going to end the meeting now. And everybody have the good rest of the week.